All right, this is lesson 10.8. It's on probability. It's really a fun lesson. Probability. Probability is simply the likelihood of something taking place. The likelihood. And the probability tells you how likely it is to take place. For example, our girls basketball team is the 1 seed, but there are 4 teams in the tournament. The probability, straight probability, is 1 in 4 that they would win the whole tournament, 25%. Now that's the probability. If you were to be a little bit more, if you would do a little bit more math and get a little bit more intricate, you could really come up with a whole different way of figuring out the odds of them winning, because they're the number 1 seed. The probability isn't odds. Probability is the possibility or the likelihood of it taking place. So don't take a gambling concept and try to put it in a probability, though at times you may think that they're similar. Probability is what's the likelihood. If there are 4 teams, then any one of the 4 teams could win. Therefore, the possibility of our girls winning is 1 in 4, or 25%. Though in reality, I believe that it's a whole lot higher than that, like 90%. All right, so it's straight probability. So what's the formula? Here's how you read this. You don't need to mark this. I'm trying to get you to think. This is the probability of event E taking place, of E taking place. That's how you would say that. What's the probability of E taking place? Well, what's the formula? The formula is the number of favorable outcomes, the number of favorable outcomes or possible outcomes, favorable outcomes, divided by the number of possible outcomes. Divided by the number of possible outcomes. That's not the greatest formula because there's a whole lot of words to it. So it's a bunch of words. And I'll show you what it means here in just a moment. It's pretty simplistic. So let's go ahead and write just the wording of this. The P says the probability. And then the E says of event E. The probability of event E. Some would say the probability of E taking place, whatever E might be. Our example, girls team winning the basketball tournament. Okay? Probability of event E. Probability can be given a couple different ways. It can be given as a fraction. If there are 4 teams, then one of the teams is going to win. There's one favorable outcome. How many total teams? 4. As a fraction, that's 1/4. It can be given as a fraction. It can also be given as a decimal. What's 1/4 in decimal form? Say it if you know it. 0.25. So 0.25 decimal, or as a percent, and that would be therefore how many? What would be the percent? 25%. All right. So fraction, decimal, or a percent. It can be given any of those 3 ways. This next one is pretty simplistic. What's the probability of a certain event? It is certain to happen. Well, the probability of a certain event is 1. Technically, probability can't go over 1. And by the way, in that same logic, what would be the probability of an impossible event? 0. Right? 0. The probability is 0. It's not happening. Hey, I'll tell you this. You know what? Fairfax girls team is not going to win the AA varsity tournament. Their probability is 0 because they're not in it. Send that out over the airwaves. All right. So probability. All right, let's do some practical stuff here. So I've got a spinner here, and you guys got a spinner on your paper. And what's the probability of spinning a 2? Well, let's go ahead and figure it out mathematically. How many 2s are there on the wheel? Say it if you know it. 1. How many total spots are there on the wheel? There is a 1/4 probability. So every 1 out of 4 spins should be a 2. That's probability. Now, this is supposed to be a random spinner. It's not a real spinner. I wish I used to do this on an overhead and had a real spinner that I would just spin. Now, does that mean every 4 times I spin, one of them is going to be a 2? Is that what that means? No. I might spin 4 2s in a row. I could do that. It's possible. Is it probable? No, but it's possible. I could spin 8 2s in a row. It's possible. Is it probable? No. Here's the thing with any probability. The fewer times you do it, the less you can really hit the probability as far as what it ought to be. But the more you do it, the closer you'll get to the probability. I'll show you what I mean. Let's spin it 4 times. Oh, come on. Don't be. There we go. All right, there's 1. All right, we're 0 for 1. 0 for 2. 0 for 3. 0 for 4. We're under the probability. Let's keep going. Oh, 1 for 5. There we are. 2 for 6. We might end up over the probability now. 2 for 7. 2 for 8. We're right on the probability now, aren't we? 2 for 8 is 1/4. The more times you do it, the closer you're going to get to that, to the mathematical probability. Unfortunately, this is why gambling houses are guaranteed to make a whole lot of money, because all the games are made to where the house has the favorable probabilities, and it's not just one single person trying to win a whole lot of money. Everybody is, and the more times they do it, the closer they're going to get to the probability, and they're guaranteed to just take people's money away. What a shame. I wish I had time to talk to you about Michael Worth, my sister's brother-in-law, who won the New York lottery for $5 million. Back when $5 million was a big deal, this was 20 years ago. It was the biggest lottery there was in the United States. He won it for $5 million. He was so excited. He didn't know what to do. He called up all his relatives and said, "Oh, man, I won for $5 million. I'm going to take care of you, man. It's great." That night he was scared, so he called the limousine service, take him from New Jersey to New York to cash in his ticket, because he didn't want to get in an accident on the way there or anything like that. And he was so scared he was going to lose his ticket. He took the ticket, he put it in his wallet, he put the wallet in his pants, he kept his pants on, and he went to sleep with his wallet in his pants in the bed that night. True story. This is my sister's brother-in-law. Because look, the ticket was $5 million. If he lost the ticket, no $5 million, right? It was $5 million, that piece of ticket. So he was scared. So of course he gets to the New York thing, and he gets to turn in the ticket, and they're saying, "Well, do you want a lump sum of $5 million? By the way, we got to take taxes out and stuff, so you only get, like 2.8 million, or do you want to take it in a yearly amount for 20 years?" And he said, "I'll take the yearly amount for 20 years." It was like 100 and something thousand a year or something. It had to be more than that. Whatever it was a good amount. And so he took but you know what happened the first thing he got home? Relatives, sorry, I didn't get that whole $5 million right now. You know how I was gonna take care of you guys? No, I really can't do that right now. Sorry about that. All the relatives said, "Oh, sure, no problem. Mike Worth with your $5 million, not a problem. We're okay with that." You think they said that? Oh, no, they weren't happy. A couple of years later, Mike burned through all his money. You know what he did? You know how he spent most of his money? Gambling. Yes, he did spend most of his money gambling. Burned through all the money. The year wasn't up. He wasn't getting his money yet. It wasn't time for it. You know what he did? He went and asked his dad if he could borrow money off his dad. How do you think the rest of his relatives felt after they were borrowing some of maybe their inheritance off of his father, the big shot $5 million millionaire? Think they were happy about that? Oh, no. Oh, by the way, 20 years later, Mike's wife left him. The kids are with the wife, and he never sees them, and he's off by himself. And the worst day of his life was when Mike won the lottery for $5 million. John, can you close that door for me? And by the way, that story's told over and over and over again. Because you know what the Bible says? Wealth gotten by vanity shall be diminished. Bible talks about us working for our money and earning what we get. That's a whole other story, but quick one there with the lottery. All right, what's the probability of yellow? How many outcomes are yellow? 2. So there are 2 yellow outcomes. And total number of spaces? 4. Now, would you leave 2/4? Of course not. You would reduce that thing to 1/2. So what's the probability of us spinning a yellow? Let's do it. Out of every 2, I got to keep getting my thing. Out of every 2 spins, 1 should be a yellow. We're 1 for 1. Look at that. We're over. We're 2 for 2. 3 for 3. We're beating the probability. 4 for 4. Right? 5 for 5. We are beating the probability. It's a random thing. 6 for 6. Very irregular. 6 for 7. 7 for 8. 7 for 9. Now, I don't have time to keep going, but I guarantee you, if I keep going long enough, it'll come out 1 to 2. I guarantee you. I guarantee you, because that's probability. Okay, so we had a streak in the beginning, but you know what? Keep spinning the wheel, and guess what? I'll tell you one more quick story. Eddie Sluzarek, my classmate growing up. He's in 11th grade. 11th grade. He goes to Freehold Racetrack. Freehold Racetrack is racetrack with trotters. Okay, so you can bet on the horses. You're not supposed to bet. He's not really old enough, but you can kind of get away with it. He's there at Freehold Raceway. He's there for the first time. And the worst thing in the world happened to Eddie Sluzarek. The worst thing in the world. Anybody know what happened to Eddie? He won. Eddie won. He won. He got 6 out of 6 yellows, man. He was, woohoo! Money. Where did Eddie spend a whole lot of his time after that? Giving all that money right on back and even more. What a shame. Because the probability will always be the probability and will always come back, and you will always lose. The house will always win. All right, that's a whole other story. All right, it's probability of red. We have a different spinner now, right? You have it on your paper. And so how many reds are there? It's my phone, so don't worry about that. There's 3. And how many total spaces? If you count them, there are 8. So our probability of a red is 3 and 8. Let's take some spins. There's 1, 0 for 1. 0 for 2, barely a gray. 0 for 3. 0 for 4. 0 for 5. 1 for 6, barely there. 1 for 7. 1 for 8. So our probability was, the actuality wasn't the probability. It was low, wasn't it? The actuality was lower than the probability. You know what? That's the way life is. Probability is just a likelihood. And again, if I spun this thing, I guarantee if I spun it 800 times, the top number would be around 299 or 300 or 301. I guarantee you. So the more you do it, the closer you get to the probability. Second probability, how would you do that one? Go ahead and write what the probability is. Go ahead and do B. What's the probability of spinning A less than 4, right? Isn't that what that says? What's the probability of less than 4? How many outcomes are less than 4? And how many total outcomes are there? Hector, what do you got? How many numbers are less than 4, Hector? On the wheel. How many numbers are less than 4? Okay, the 3 is a less than 4, so there's 3 3s. A 2 is a less than 4, there's 2 2s, and a 1 is a less than 4. So there are 1, 2, 3, 4, 5, 6. 6 numbers on the wheel that are lower than 4, because we know what that symbol means, right? It's a less than, and we know what less than means already. And how many total are there? 8. And of course, you reduced your fraction to 3/4, right? Probability, 3 out of every 4 spins will be less than 4. 0 for 1. 0 for 2. No, 1 for 2. 1 for 3. 1 for 4. No, thank you, but thanks for asking. Whose birthday? Happy birthday. How old are you? 87? 13. 9. Awesome. Happy birthday to you. All right, so again, we were lower than the actual probability, but that is life with probability. Let's go on the next page. This will help you if you're a game player. Anybody play Settlers of Catan? Anybody play that game? Okay, I like that game. If you know this, that will help you in the Settlers of Catan. I have 2 game cubes. Some people call them dice. That's gamblers call them dice. I like to call them game cubes. I have 2 game cubes, and we're going to figure out the probability of rolling. Now, Monopoly uses 2 game cubes. Catan uses 2 game cubes, and a lot of other games use 2 game cubes. So these probabilities will work in any game that uses 2 game cubes. Now, what I listed for you are all the possibilities. Would you agree I could roll a 1 with the first red one? But the blue one could be anywhere from 1 to 6. Is that not possible? Or I could roll a 2 with the red one, and the blue can still be anything 1 through 6. I could roll a 3 with the red one, and the blue could be anything 1 through 6. I could roll a 4 with the red one, and the blue could be anything 1 through 6. I could roll a 5, and the blue could be anything 1 through 6. I could roll 6, and the blue could be anything 1 through 6. All right, so let's do the probability. What's the probability of rolling doubles? Go ahead and take your green pen out, and let's just circle or square in the doubles. There's 1 set of doubles, right? There's 2 set of doubles, and you can see they're going on a diagonal, right? 4, 5, and 6. We have 6 sets of doubles. Anybody figure out how many total possibilities there are with 2 game cubes? What's the total? Say it if you know it. There are 36. There are always 36. So again, we would want to reduce this. And the probability of doubles is 1 in 6 rolls. Don't you have to roll doubles in Monopoly to get out of jail? Well, there's a 1 in 6 chance. I've seen people do this. They roll, don't get out of jail. They roll, don't get out of jail. They roll, they don't get out of jail. They roll, they don't get out of jail, and then they pay. It's like, if you're going to pay in the beginning. Because you have 1 in 6 shot. So you might go 6 in a row and never roll those doubles. But probably 1 out of every 6 rolls will be a doubles. Settlers of Catan, rolling doubles. No, that doesn't do the robber. 7 does the robber in Settlers of Catan. How many 7s are there? 1, 2, 3, 4, 5, 6. Matter of fact, a 7 is the same probability, a 1 in 6, that you'll roll a 7. Here's Settlers of Catan. The 8 spots are quite important. So I'm going to do these. I'll use black here. What's the probability of rolling an 8? Right? That's what we're doing. And so where are the 8s? All right, 2, 6, 3, 5, 4, 4, 5, 3, and a 6, 2. 1, 2, 3, 4, 5. 5 of 36 rolls probably will be an 8. How about something like a 3? Can only happen 2 times. 1 out of 18 for a 3. That doesn't happen too often. 4, 1 and 3, 2 and 2, 3 and 1. 3 out of 36. Again, people that know this can do a little better in some of those games because they know the probability of what they're going to roll. Here, let's roll a few. Let's go for the doubles. Say we were in jail. Let's try to get out. All right, 4 and a 5. I'm not out yet. There's a 6. 6, by the way, also is the same as an 8. 5 out of 36. Oh, doubles on the 3rd roll and an 8. and an 8. All right, let's do another set here. Let me change it up so they're not even to start with. Here we go. Roll 1. Ah, doubles on roll 1. Not an 8, though. Roll 2, a 7. The robber would be out. 6, that's a high probability. Ah, doubles again. 6 again, high probability. 7, robber would be out. Hey, have you played a game where you never roll doubles at all, the whole Monopoly game? I've done that. So again, remember, this is probability. The more times you do it, the closer you'll get to the actual probability. Anytime you use 2 game cubes, there are always 36 choices. And by charting it like this, it's pretty easy to see how many then outcomes there are. And that's what you'd have to think through if you were asked a question like that. Gamblers, their important rolls are 7 and 11 if they usually roll dice game. You know, again, these people aren't fools. If you go into a game with somebody, they're going to know all these probabilities. They're going to know the probability of a 7 is 1 in 6, and they're going to know the probability of an 11 is a 6 and 5, and a 5 and 6, only 1 in 18 chance of rolling an 11. And they'll know every other number in between. They'll have it memorized. But if you're playing a game, it does help to know the probabilities. All right, let's do a couple more things here. The word or. What if they use the word or in writing the probability? Come on. What if they use the word or? Well, the word or implies either one. Either. Either one. Now, I did make a mistake on your sheet here. This 9 is supposed to be a 3 because there are no 9s on the wheel. That would be an impossible event. So when they say a 2 or a 3, your possible outcomes are, whoops, let me go back here. How many 2s are there? There are 2 2s. And how many 3s are there? There are 3 3s. So there are 5 total possible outcomes. Any 2 or any 3 is what we're trying to find the probability of. How many total here? 8, right? So this is 5 8s. 5 out of 8 spins should be a 2 or a 3. Let's see what our spinner does this time. There's 1. Up, 1 for 1. 2 for 2. 2 for 3. 3 for 4. 3 for 5. 4 for 6. 5 for 7. And we're a little ahead. 6 for 8. Again, but that's probability. Does it mean that's exactly what's going to happen? No. But it's the probability. All right, so go ahead and try to do B there. What's the probability of spinning either an even or blue? Even or blue. What's your probability of spinning an even or blue? Even or blue. Even or blue. All right, hopefully you say there are 1, 2, 3 evens, right? And I'll keep doing it this way. There are 3 evens, and there is 1 blue, and there are a total of 8, so it would be 4 8s or 1/2, right? How many got that correct? Probability is not hard if you understand what's going on. Or means it could be either or, right? Or. Either or. The second scenario is the word and. This is a little different. The word and. The word and is used, it must be both to be an outcome. It has to be both. Both have to take place. So when we say the probability of even and yellow, what are we talking about here? What does that mean when that word and is used? Andrew? It can only be the two that's yellow, correct? Because it has to be both even and yellow. And there's only one even yellow spot. So the top number would be just one. And the bottom would be the 8. There's only one thing that can turn out to be both yellow and even. So it's a 1 in 8 probability. So try to do B there. What's the probability of less than or equal to 3 and red? Less than or equal to 3 and red. What's the probability? Go ahead and see if you can figure it out. What's the probability of less than or equal to 3 and red? What is that probability? All right, who wants to give it? Anybody? Devin, what do you got? How many agree with Devin? 3/8. Right? There are 3 of them. Here, I'll do it the split way like I did before. Less than 3 and red. Okay, well, yeah, there's just no other way but to list it. So this red 3 is less than 3 and red, less than 3 and red, less than 3 and also red. And so 3/8 is the probability. Okay? So again, that's what you're looking at. That's how you're doing these. Oh, I got one more page to go? No. I was thinking about my coin flips. Where are my coin flips? Oh, my coin flips are tomorrow. Well, Monday. All right. So those are coming up. All right, one other term here I need to give you. It's a pretty simplistic term. You may have heard it before, not knowing what it meant. It's the term mutually exclusive. Mutually exclusive events are those that cannot occur at the same time. Our girls basketball team cannot win today's game if the team is also visiting Richmond today from 2 to 5 p.m. Those are mutually exclusive events. Can't be in two places at once. They can't do both. It's impossible. Now, could our girls team win the game today and also lose the tournament? Yes. Will that happen? No, but that's not mutually exclusive. Mutually exclusive events are those that can't occur at the same time. Any questions? Any questions? Anybody? Jack? No, you just have to look at the situation. There are a little bit more sophisticated formulas. Everybody look up here for a moment, please. For the or and the and, you can mathematically make a little bit more sophisticated formula for those, but it's so much easier, I think, just looking at it common sense wise. Or means could be either one. 2 or 3, which ones are 2 or 3s? And means it has to be both, even and yellow. There are mathematical formulas for those, Jack. I don't think they're worth the time because they're just common sense will get you where you need to on those. All right, here's your homework. Page 435. You guys do 1, 2, 5, 6. I don't know why I have now 7 through 10, but it must be a different section. Sorry about that. 7 through 10. 13, 14. 31 through 34. 53, 54. And I need you to open your books up so I can mention something to you.